Fermilab and MIT Lincoln Laboratory have successfully trapped and controlled ions using electronics that sit right inside the ultra-cold vacuum chamber. This is the first time it's been done at the temperatures quantum computers actually need, near absolute zero. Here's the problem it solves. Quantum computers, especially the ion trap kind, need to be colder than outer space so the qubits stay stable. But the control electronics that move the ions around and read their states usually sit outside the chamber. All the wiring and heat leaks ruin the cold. Scaling up to hundreds or thousands of qubits becomes almost impossible. Now they've built cryoelectronics, special chips designed to run at those extreme low temperatures, and placed them inside the vacuum. The result? They can move individual ions, hold them in place, and measure signals with way less noise and heat. This proof-of-principle experiment was a collaboration between two big DOE quantum centers, the Quantum Science Center and the Quantum Systems Accelerator. It shows that you can co-locate the control hardware right next to the qubits without destroying the quantum magic. Picture this: tiny ions floating in a perfect vacuum, controlled by chips that are basically at the same frigid temperature. No long wires carrying heat. Cleaner signals. Easier to add more qubits. That's the path to real, large-scale quantum computers that can solve problems classical machines never could. Drug discovery, materials design, breaking encryption, you name it. The researchers say this is a key step toward practical ion trap quantum systems. And because the cryoelectronics are made with existing semiconductor tech, it could scale up faster than people thought. So yeah, a quiet breakthrough in a freezing vacuum chamber just moved quantum computing a giant step closer to reality. This is how the next computing revolution actually gets built. One cold chip at a time.